while going through these questions, I'll also be taking into account certain things that you should be doing in the exam. For example, looking at the significant figures, looking at decimal places, and basic exam technique. So let's start off with the first question. When attempting an exam question, it's always good to highlight any key information and read the question from the beginning till the end. Sometimes you look at a question and you just start attempting it without actually reading the key information. So it's always best to highlight the key information. So the figure below shows a uniform steel girder. That's important. Uniform. What does that mean? That means that weight is distributed across the whole object equally. It's being held horizontally by a crane, and 2 cables are attached to the ends of the girder, and the tension in each of these cables is T. So tension in each of the cables is T. Now, if the tension T in each cable is 850 newtons, let me now write that down here. That's something that I'm paying attention to. It wants me to calculate the horizontal component of the tension in each cable, and then the next part says the vertical component, and then finally the weight of the girder. So let's tackle the first one. I need to do the horizontal component. So I know that this is my force T, and it's acting at an angle of 42 degrees. It wants me to calculate the horizontal component in each cable, so not together, just each. That means it wants me to calculate this one here. Now, I can only work out one of them because I know T is the same in both and the angle is the same, so I don't need to treat each one separately. Now, I have 850 newtons acting at that angle of 42 degrees. If I want to bring it down to the horizontal plane, I have to go through my angle. So to go through my angle, I have to use our little technique that I've shown you in class. When you're going through the angle, it's like closing a book. So closing, C, begins with cos, C, so it's a cos. So you're going to use the cos function. And if you're going away, that is when you use the sine function. So in this case, to go through the angle of 42 degrees, I will do 850 cos 42. And if I put that into my calculator, that will give me 631.6731. Now, let's look at the question. The question is giving me this 850 to 2 significant figures. This 42 degrees is also to 2 significant figures. So that means my answer must also be 2 significant figures. So I will leave this as 630 newtons. I'm following the accuracy of my question. The next part is the vertical component of the tension. So I'll just focus on this part here so that I'm keeping the question diagram clean. Now I need to go away from my angle of 42. So going away, it would be 850 sine 42. So I'll put that in over here. 850 sine 42. And if I do that in my calculator now, that will give me an answer of 568.7610. So again, following the 2 significant figures rule, this will be as 570 newtons because I've rounded it to 2 significant figures. Now it's saying calculate the weight of the girder. So it's basically asking me to find the weight of this thing here. I've just highlighted in green. Now the weight we know is going to be acting downwards. If this object is in equilibrium, what that means is that the upward forces must equal the downward forces, and the resultant force is 0. So in equilibrium, if we have anything in equilibrium, it means that it must have 1, balanced forces, and resultant force must be 0, or 0 newtons. So to calculate the weight, I know that my weight is acting down, so I'll draw a little quick diagram, make it into a free body diagram. So I'll put an arrow there, I'll make it into a free body diagram. So I know I have my girder here, let's define that as my girder there. I have weight acting down, and there's tension in each string, and they're both acting upwards if you were to resolve them vertically. So I have T there. Now that's wrong because I have two strings, right? And so there's twice the tension. So this is in fact 2T. Not 2T as in 2 times 850, but 2T vertically. So I put a small v there to represent that that is tension in the vertical plane. Now we've already calculated tension in the vertical plane. We just calculated it here, and that was 570. So that means that 2 times 570 will give me my weight of the girder. So that is 1,140 newtons. And so that's how I would attempt part 1A of this question. Now, in the next part of the question, it's saying on the figure, draw an arrow to show the line of action of the weight of the girder. So I've already sort of drawn that here. But what I'm going to do is I'm going to rub out that one there. The line of action, if I just draw it there, that would be weight.